Hello and welcome to another exam paper walkthrough. Thank you very much for joining me today. Today we're going to be focusing on a GCSE Maths paper, and this is going to be a past paper. Past papers are excellent revision for any upcoming exams, one of the best forms in my opinion. Today I'm going to be focusing on an AQA paper, although this will be great revision for any exam board. And the paper I'm going to be looking at is the November 24, so quite a recent one, and we're going to be looking at a higher paper 3. Attached to the description to this video, you'll find a link to a Google Drive where you can download a copy of the paper. If you've not already done the paper before watching the video, I'd recommend having a go at the paper before watching the video, or do it alongside, either way, to get the most out of the paper and the video. I'd also recommend a bit of music on in the background. It just makes it go a little bit easier. I always record these videos with an ear pod in, listening to some music in the background, and I'd recommend the same for you guys. If you find this video useful, please do subscribe, and you'll get notifications as soon as any other videos are released. I'll be releasing plenty in the build up to the exams, so please give that subscription a quick hit. Right, let's get started with the paper then. Okay, for today's video, I'm going to be attempting to use the more modern version of the Class Whiz calculator as opposed to my usual one. Just trying to get used to it. This is an emulator package that I've got. This is on an online version, which is slightly more complicated to work, but hopefully we should be fine with it. Right. Okay, let's get started then. Question 1. Work out the reciprocal of 10 thirds, given your answer as a decimal. So the reciprocal is essentially switching the numerator and the denominator's position. So this is going to become 3 over 10. And 3 over 10 as a decimal is 0.3. Question 2. The table shows information about the number of houses with solar panels in a town. And we've got our years, and we've got complete the graph. Right, so if we zoom in a little bit, so just double check the values that have already been plotted. 2017 is 50, correct. 2018 is 65, yep. 2019 is 115, brill. Right, so 2020 is 210. So 210 is going to be one small square above the 200 mark. 2021 is 275. So 2021, 275, halfway between these two. So we go in there. 2022 is 350. So 350 is hitting slap bang there. Right. We need to make it clear that we're joining these with a straight line rather than a curved line. So I've got a ruler on my screen. It's not perfectly straight because I'm trying to do it digitally, but you can get the idea. You should look a bit more straighter than that, but there we go. I'm going to imagine they're going to ask us to do a prediction now. Use the graph to estimate, the number of houses in 2023. So we want to, I'll change pen color just to, so we want to carry on with this pattern. So carry on roughly, and then there's going to be a range of values acceptable here. Let's just say there. So that's following roughly the pattern. So we're looking at, from my value, 415. But provided you're following that pattern, there'll be a large range of values that are acceptable, probably anything between, realistically, arguably 350 to 450, but I'm going to go 415. Question 3. A building in the shape of a cylinder has a diameter of 40 meters and a height of 55 meters. On the centimeter grid, draw a plan of the building using a scale of 1 centimeter to 10 meters. Right, so if we've got a diameter of 40, then our radius must be 20 meters, which is going to be, I want to draw a circle with a radius of 2 centimeters on here. I'm going to take this over to Word just because I can do a circle in Word a lot easier. Okay, so I want a circle that's going to go through these coordinates, not these coordinates, these points. So I'm going to insert, but obviously we'll open our compass arms, 2 centimeters or two of these squares. We'll place the point in the center and we'll place our pencil at one of the points and draw a perfect circle. I'm going to insert a circle and just change it that way. Right, so we're going to go there to there, and then I'm going to make it wider to there and wider to wider, hopefully. It's not really letting me do that, which is a bit frustrating. Try it with my mouse rather than my pen. There we go. Okay, I'm just going to change that to no fill, and I'll change the outline to red just to keep it consistent. So there we go. So we've got a circle that's 2 centimeters from that point. Okay, so I'll go on Word just for my own notes. Right, second part. Actually, we'll draw a quick sketch of it. You can see my freehand circle's not very good. Right, part B. On a centimeter grid, draw the front elevation of the building using a scale of 1 centimeter to 10 meters. So let's go back and look at our dimensions. 40 meters by 55 meters is going to become 4 centimeters by 5.5 centimeters. So we're looking 4 centimeters across and 5.5 down, 2, 4, 5. Let me just change that slightly, give myself a bit more room. 2, 4 across, 2, 4, 5.5 down. Okay, so then we use our ruler to draw our rectangle. There we go. Right. Question 4. To the nearest pound, Rosie has 12 pounds. She wants to buy 6 drinks. Each drink costs £1.89. Show that Rosie definitely has enough money to buy the 6 drinks. So if Rosie has got £12, the minimum she could have, because that's to the nearest pound, the minimum she could have is going to be £11.50, because that's the smallest value that we would round up to 12. And then if we want 6 drinks, so we're going to go 6 times by £1.89, and then hopefully that's going to be less than £11.50. Oh, still got Word open there. There we go. So 6 times by £1.89 is going to give us, as a decimal, £11.34. And then we can just say £11.34 is less than £11.50. Right, question 5. The total cost of a taxi ride is calculated by adding a fixed charge of £4 and then a charge of £2 per mile. Write a formula, so we don't need a calculator for that. Write a formula to work out the cost in C of a journey of n miles. So we've got a fixed charge, so that's going to be a flat £4 plus £2 per mile, so that's going to be 2m. So 4 plus 2m. We could factorize that, but there's no need to, so we'll leave it like that. Right, question 6. 3 shops sell shirts. Shop A sells them in packs of 2 for £19. Shop B was £12.40, now with 25% off. And Shop C, packs of 3, £37.40. Buy 1 pack, get another pack half price. Which shop is cheapest to buy 6 shirts? Okay, so if we're using Shop A, so I'm going to go SA for Shop A. To work out our total cost for 6 shirts, It doesn't ask us by how much, but that we'll work out the price for each anyway. So we want to do 6 divided by 2 because that'll tell us how many packs of 2 we need. And then we're going to times that by 19. For shop B, we're going to do, we need 6 of these. So we're going to go 6 times by £12.40, not 1.24, £12.40 times by, if we've now got 25% off, we're only paying for, it means that we're paying for 75% of each. So we're going to times that by 0.75, and that'll give us our shop B price. And then for shop C, packs of 3, buy 1 pack, get another 1/2 price. So if we want to buy packs of 3, we want 2 packs of those, 1 at the full price and 1 at a half price. So for shop C, we're going to pay £37.40 times by 1.5 because we want 1 and then a half. Right, and then we'll go to calculator for all 3 parts then. So first of all, we're going to do 3 times by 19. So for shop A, we're going to be paying £57. For shop B, we're going to pay 6 times by £12.40 times by 0.75. So for shop B, we're going to be paying £55.70. Sorry, 80. £55.80. And then for shop C, £37.40 times by 1.5. So that's going to be £56.10. So which one is the cheapest price? That would be shop B. Let's just reread the question, double check we don't need to state the price. At which shop is it cheapest? So that's all we need, shop B. Right, question 7. At a school, there are 912 students. The ratio of students to teachers is 15.2 to 1. The number of students stays the same. The number of teachers increases by 2. Work out the new ratio of students to teachers, giving your answer in the form n to 1. Okay, so we're going to stick with the ratio version for this, I think. Students to teachers, we're starting off with 15.2 to 1. We've actually got, so that's the simplified ratio. If we build it up to the original ratio, 912 students. So to get from there to there, we need to do 912 divided by 15.2. So we're timesing by 60 there. So if we times by 60 on the other side, we'd get 60, obviously. Right, now, that's the original version. Now, the number of teachers increases by 2. The number of students stays the same. And then we want this in the form of 1 to our mystery number. So here we're dividing by 62. So here we need to divide by 62. So 912 divided by 62 gives us 456 over 31. And we'll go decimal because our answer here is in decimal. Not our answer, our number here is in decimal. So if we go decimal here, that's going to give us 14.7096 ... So no rounding shown. And then to round it, I like to go one more than the question. So we've got 1 decimal place here. So if it's not stated, I always like to go 1 degree more accurate than the question. So I'm going to go 14.71. Although 14.7 will be absolutely fine. Part B. On a school trip, 1 teacher is needed for every group of 10 or fewer students. 72 students want to go on a trip. Lexi tries to work out how many teachers are needed. 72 divided by 10 equals 7.2. 7 teachers are needed. What is wrong with her answer? She shouldn't have rounded. She shouldn't have rounded down. 7 teachers would only cover 70 students. She should have rounded up to 8. So 7 teachers can only cover 70 students. She would need 8 teachers for 72 students. That's not very clear written of students. Let's try that again. Slightly better. Okay, question 8. Triangle is drawn using the lines y is equal to x, x is equal to -2, and y is equal to 4. Work out the coordinates of the 3 vertices of the triangle. So this was on the crossover, so this is on the foundation tier as well. For the foundation tier, I would definitely recommend drawing the 3 lines. For the higher tier, I reckon you can get away without drawing the lines. So we've got to kind of imagine we would have the point where this meets the line y is equal to x, so that would be -2, -2. We'd have the point where this meets the line y equals x, which would be 4, 4. And we have the point where these 2 lines would intersect, which would be -2, 4. And we don't need to draw the 3 lines, find the points of intersection, although if you feel more comfortable doing that, there's nothing wrong with that. Okay, question 9. When x is divided by 2, the remainder is 1. When x is divided by 3, the remainder is 1. When x is divided by 4, the remainder is 1. Work out 2 possible values for x. So let's think about this. So if we're saying when it's divided by 2, 3, and 4, each time it's got a remainder of 1. So it must be 1 more than the lowest common multiple of 2, 3, and 4, or a common multiple of 4, of the 3 numbers, sorry. So if we find the lowest common multiple of 2, 3, and 4, well, you don't really need to worry about the 2 because 2 and 4 are multiples of, well, no, 4 is a multiple of 4. 4 is a multiple of 2. So we really want the lowest common multiple of 3 and 4 to start with. So the lowest common multiple is going to be 12. So 1 more than 12 would be 13. 1 more than, so another common multiple, any factor of 12, or any multiple of 12, sorry. So we could go, our next one would be 1 more than 24, so 25. Could carry on. So 1 more than 36. So 37. 1 more than 48. So 49. Any of those would be absolutely fine. I've gone for the lowest 2 though. Okay, question 10. A car drives 60 miles. Draw a graph to show the average speed of the car for times taken between 1 hour and 6 hours. You may use the table to help you. A car will travel 60 miles. Draw a graph to show the average speed of the car for times taken between 1 hour and 6 hours. Okay, so yeah, we'll carry on with the table version. So we've got they're just going to be multiples. So 20, 15, and 12. So 60 and 1, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 1 and 10. And then we join those with a curve. So easiest way to draw a curve is to keep your wrist on the inside. So my wrist is kind of being here. And then we Obviously doing it on a screen is not going to be perfectly curved, but that's a good enough approximation. And again, tip for drawing a curve, keep your wrist on the inside. Question 11, factorize fully. So we can take out our number part first of all. We can take 4 out as a common factor, and they've also both got a t in common, so we can take 4t out as our common factor. And then that would leave us with, what do we need to multiply 4t by to get 12t? That would be 3. And what do we need to multiply 4t by to get 4t cubed? That would be 4t squared. And then we've got a plus in the center. Question 12. The population of a country is now 67,200,000. The population is predicted to increase by 1% per year for 6 years and then decrease by 1.2% per year for 2 years. Work out the predicted population for the country 8 years from now. Okay, so a 1% increase would be a multiplier of 1.01. And then a decrease of 1.2 would be a multiplier of 0.988. Just in my head. Yeah, that's right. Okay, so our total, give your answer to 3 significant figures. That's a good point to spot. So I'm doing 67,200,000 times by 1.01 to the power 6 times by 0.988 to the power 2. And we can do that as a single sum. We don't need to break it into separate parts. So 67,200,000. Just check I've got the right number of zeros there. 5. Yep. Times by 1.01 to the power 6 times by 0.988 squared. So that gives us 69,632,406.54. But we want it to 3 significant figures. So first, second, third significant figure. So we're going 69,600,000. Question 13. A bag contains 1 £5 note, 1 £10 note, and 1 £20 note, and 1 £50 note. Amir picks 2 of the notes at random without replacement. Work out the probability that he picks at least £30. Right, okay, so let's think about this. So if he picks a £5, if one of the notes is a £5, the other note must be a 50. Plus the probability of picking, he could do it with a £10 note and a 20 or a 50. He could pick 20 and a 10, which we'd already covered, so we don't need to worry about that. Or a 20 or a 50. So probability of picking a... No, we do need to include the 20 first. Yeah, because probability of 20 first, and then either a 10 or a 50. And then plus the probability of picking a 50 and anything else. 0 is not, and then X, any of the others. Right, so the probability of picking a 50 first. So there are 4 notes. 1, 2, 3, 4 notes. So the first one is going to be 1/4 times by 1/4. No, not a quarter the second time because we've only got 3 left. So times by 1/3 plus probability of picking a 10 first of all. Sorry, no p there needed. 10 first, and then a 20 or a 50 is going to be 2/3. This one's going to be exactly the same, so we're going to times that one by 2. And then the probability of picking a 50 first of all is going to be just 1/4. There's no need for anything else. Right, so technically, we can go to our calculator here. I'm going to be slightly crafty though. Let's just, so if we take a quarter out as a factor, we can say that that's going to be 1/3 plus times those 4/3 plus 1. So that's actually going to be 5/3 plus 1. So 1/4, we've got 5, 6, 7, 8/3. And then if we do that multiplication, so that's just going to give us 2/3. No need for the calculator there. We could jump to the calculator right at the beginning here if we wanted. There's nothing wrong with that. Just to double check our working. Times by 1/3 plus 1/4 times by 2/3 times 2 plus 1/4. Yeah, 2/3. Right, question 14. Test consists of 2 sections, A and B. 85% of people who pass section 85% of people pass section A. 78% of people who pass section A also pass section B. 36% of people who fail section A also fail section B. Complete the tree diagram. Okay, so important aspect to this tree diagram is we've got a decimal here. So we're going to keep everything in terms of decimals. So 85% pass section A, so that's 0.85 there, which means we've got 0.15 there. We've already got that one filled in, so that's going to be 0.22 there. And then 36% of the people who fail section A also fail section B. So that's 0.36 there, which means that we've got 0.64 there. So there's our tree diagram. Part B, 40% of people who fail at least 40% of people who fail at least one section take the test again. 5,000 people take the test. How many of these 5,000 people are expected to take the test again? Okay, so the first thing that we want to work out is the number of people who fail at least one section. Right, so fail at least one section is going to be 1 minus the probability that they pass both. So pass. Right, so we'll work out what that is. I was just trying to work out whether to try and work that out. Pass is 0.85 times by 0.85 times by 0. I can't remember what that was. I think it was 7/8. It was 7/8. So that's going to give us 1 minus 0.85 times by 0.78. So, and that's fine, to be fair. We could do it as a decimal, but there's no advantage to converting it to decimal. So that's the probability of somebody failing at least one section in the test, at least one section. So we want to do that times by 5,000. So I'm just going to do all my answer, my last answer times by 5,000. So times by 5,000. So we would expect 1,685. And that is the people, that's the number that will fail at least one of the tests. So finally, we want to work out 40% of that. So if we times that by 0.4, that will tell us the number that will take the test again. So times that by 0.4 gives us 674. Yeah, so 1,685 is the number who will fail at least one of the tests, but we want 40% of that for 40% who fail will take it again. Okay. Right, match each equation to the statement to show what happens when the value of x is doubled. Okay. I was going to say we can get rid of the calculator, but we don't really need to. So what happens when the value of x is doubled? So x is going to be replaced by 2x in effect. Okay, right, we're going to kind of switch x for 2x. So this one would become y is equal to 16x. This one would become y equals 5 over x, because it would be 10 over 2x, which simplifies. Y is equal to 3x squared. For x, that would become y is equal to, I'm going to do 2 steps for this working, 2x squared. So that's going to become 4x squared, 4 times 12x squared. Right, so that's what they would become. Which one of these? The value of y is doubled. The value of y is doubled. So these are actually slightly different to what I was expecting. So I'm going to rearrange these a further step, because they're all talking about what happens to the value of y, which I should have spotted up here. So if I convert these back to having, if I convert this back to having 8x there, so 2y is now equal to 8x. And then I want 10 here, so this would become, so if I wanted, so let's rearrange this one a bit. So that's 2 lots of 10 over x, which would be y over 2 is equal to 10 over x. So that should be an x there. Miswrote there. This one compared to the original, so I would want to say that y equals 4 lots of 3x squared. So y over 4 is equal to 3x squared. So now we've got how it affects y. So this one is doubled. This one is half. Let me change the colour for this just to make it clear because of all of my working. Right, so that one is doubled. This one is halved. And then this one is, the value of y is multiplied by 4. So that's that one. Right, question 16. Rearrange y is equal to the root of, to make x the subject. Let's change pen color back to red. Okay, so my first step is I want to square both sides. So y squared is going to be equal to x over 2 plus 1. Then I'm going to minus 1 from both sides. So y squared minus 1 is equal to x over 2. Then I'm going to multiply it by 2. So 2 lots of y squared minus 1 is equal to x. Now x is the subject, so x is equal to, we could multiply that out, but I don't see any advantage. I think factorising is quite neater. Question 17. A stone falls vertically from 200 meters above ground. The stone falls d meters in t seconds. D is directly proportional to the square of t. The stone falls 20 meters in the first 2 seconds. Work out the total time taken for the stone to reach the ground. So for this one, I'm just trying to work out the better method. So we could use direct proportion equation, or we could use the ratio method. Now, the ratio method is much less widely done. However, I like it. Not that you need the history of it. So direct proportion has always been in the GCSE spec, but on the 2017, it was kind of moved into the ratio and proportion, which implied that you could do it with the ratio method. And I find the ratio method slightly easier, so I'm going to do it. So we've got directly proportional to the square of t. So that means if we're looking at the ratio, d to t squared. Now this is a slight red herring. So because the stone falls 20 meters in the first 2 seconds, find the total time for the stone to reach the ground. So that's actually when d is equal to 300. So we start at 0. It travels 0 distance in 0 squared. But then this is the first point that we're given. So the stone falls 20 meters in the first 2 seconds. So d is proportional to t squared. So that would be 20 to 4. So that means that we've got whatever value we've got here, we divide by 4 to find t squared. So for 300, that's going to be 300 divided by 4 is going to be, divided by 5 is going to be 60. And that's t squared. So for 300, we're just looking at the square root of 60. So for it to travel 300 meters down, we're looking at root 60. So my root is root 60, execute, so 2 root 15, which would be 7.745 ... So we're looking at 7.7 seconds. If we wanted to do it using the proportion equation, though, I'll do that method as well because I think that will be the more common one. So d is proportional to the square of t, so d is equal to k t squared. And then we put in our initial values, so 20 is equal to k times by 2 squared. So that's 4, so 5 is equal to k. So d is equal to 5t squared. And then we want to find when d is 300 is equal to 5t squared. So 60 is equal to t squared. So root 60 is equal to t. So that's using the equation version. You actually do the same math. It's just a slightly different way of setting it out, really. Right, question 18. Table shows information about the height of 40 plants. So initial snapshot, I think this is going to, a histogram question. Okay, great. Class width, draw the histogram. So class width is 5, is 10, is 10, is 25. Let's just check those. 10, 10, okay. So we're going to have frequency density here. I'm going to put FD. Frequency density is equal to frequency divided by class width. So 6 divided by 5 is going to be 1.2. 1.2. 15 divided by 10 is going to be 1.5. 9 divided by 10 is going to be 0.9. And then 10 divided by 25 is going to be 0.4. Right, so we want our frequency density, our max value is 1.5. So we've got quite a big range to, how many squares have we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so not set up particularly nicely. So we decide our scale for ourselves. 0.2, 4, 6, 8, 10. Yeah, we'll go up in 0.2s. So 0.2, 0.4, 0.6, 0.8, 1, 1.2, 1.4, 1.6, 1.8. We don't need any further than that then. Right, 0 to 5 is 1.2, so 1.2. Then we've got 5 to 15 is going to be 1.5. I'm just kind of putting on my key points, and then I'll use my ruler in a moment. So 15 to 25 is 0.9. And then finally 0.4 up to 50. Right, we'll get our ruler out now, and then hopefully we've set ourselves up nicely. Ooh. My hands getting in the way. Okay, so there's my histogram. Does it ask a follow-up question? I don't think it's going to. Okay, there we go then. Right, question 19. Use the sine rule to work out the length of x. Okay, so I'm going to call this A and this capital A then, and we'll call this B and this capital B. So, and we want the version for the side, so we're going to say A over sine A is equal to B over sine B. Right, I'm going to rearrange and substitute in. So I'm going to say that x is going to be equal to B 54 over sine of 117, sorry, times by the sine of 35. Okay, and we'll type it in just like that, 54 over sine 117 times by sine of 35. So that gives us 33.524 6 dot dot dot. It doesn't say a degree of accuracy. We've got 3 significant figures, so I'm going to go 4 significant figures. So 33.52. And I've just spotted, and this is a good one to check for you guys as well. So my calculator is actually in radians. Can you see that little R there? And I need it in degrees. Right. So to switch this into radians on the more modern forms, we go settings, we want calculator settings, we want angle input, and we want to switch it from radians to degrees. Okay, so does that automatically affect? There we go. So I'm going to get rid of that answer and just switch it for degrees. So we're looking 34.7619. So that's going to be 34.76. If you're using the other version of the calculator to switch it, we've got angle unit, and we want number 1 degrees. So should have checked that at the start of the video, but there we go. Right, question 20, factorize fully. Okay, so we've got non-monic quadratic. However, the only way that we can make a 3x is by a 3x and a 3x squared is by a 3x and an x. Then we've got a couple of options here. We're still looking for 2 numbers that multiply together to make 30. But this time, because of this 3 lots of one of the numbers plus the other number multiply together to make 23. So initially we can say both values have to be positive. And then for 30, we've got, we could do, well, 30 and 1 wouldn't work. We could have 2 and 15. I don't see that working. 3 and 10. Don't see that working. So 5 and 6. 5 and 6 will work because if we had 18, so 6 there and 5 there, that would work. So we're looking at the 3 and the 6 being in opposite brackets. So that's going to be our factorized version. So 3x plus 5 and x plus 6. Right, question 21. A bag contains 25 discs, 11 are red, 9 are blue, 5 are yellow. Ashley picks 3 of the discs at random without replacement. Ashley's first disc is red. Work out the probability. Ashley's first disc is red. Work out the probability that all 3 discs are different colors. Okay, so if we're assuming that the first disc is red, so no, not assuming, the first disc is red. Probability of picking a blue from the second disc is 9 out of 24. And then she would need to then pick a yellow disc. There are no longer 24, there are only 23. That's the probability of picking a red, then a blue, then a yellow. Or there's the probability of picking a... Let's rewind that slightly. So we want to find the probability of picking... We've already got red for the first one, but after the red, so red and then blue and then yellow. Or the other option is the probability of it being red for the first one, which we've got to assume has happened, well, which has happened, yellow, then red. Then blue. So that's going to be, we've already picked red, so it's the probability of picking, after having picked red, probability of picking blue, which would be 9 out of 24, times by the probability of picking yellow, which would be 5 out of 23, plus probability of picking, after having picked red, probability of picking a yellow, which would be 5 out of 24, times by 9 out of 23. Now that's actually going to just be 2 lots of 9 times 5 over 24 times 23. Have we got any nice simplifications? We could say that's 17s, but that's not particularly an advantage, but we'll do it anyway. 9 out of 14, sorry, times by 5 out of 23. So 9 out of 14 times by 5 out of 23. And I've messed up here. That should have been half of 24 is 12, not 20, not 14. So let's just change that. So 15 out of 92. Right, question 22. The metal used to make a sphere costs £4,320. The metal costs £3.60 per gram. Each cubic centimetre of metal has a mass of 17.3 grams. Work out the radius R of the sphere. So the first thing I want to do here is to work out the volume of the sphere based on the price and the cost, total price and the cost of the sphere, and then the cost of the metal and the centimeters per gram. So what I'm going to do is the total cost divided by the cost per gram times by the mass per centimeter. So times by 17.3. Right, so that's going to give us 4,320. No, I've mistyped. 4,320 over 3.6 times by 17.3. So that's going to give us our volume. So our volume, we'll stick with that version though, 1200 divided by 173. So we know then that the volume is this. So I'm going to say that the volume is equal to 4/3 pi r cubed. So if we say the volume times by 3 divided by 4 pi is going to be equal to the radius cubed. And then I'm going to cube root my answer. Cube root my answer. And that'll give us the radius. So here's our volume. So we're going to times that by 3 over 4. That shouldn't 4 pi. So the pi button on here is shift pi. And we want to cube root that. So cube root is, have we got cube root here? Got square root, so we're going to shift, we'll do it there, 3 cube root my answer. So I get 2.5488 ... is equal to R. Okay, so I'm going to round this then. Let's see, 3 significant figures, arguably 3 significant figures, 3 significant figures. So I'm going to go 4 significant figures. So I'm going to go 2.549. Question 23. The distance of a particle from a point is d meters after t seconds, where d is equal to a times by b to the power t, where a and b are constants. Okay, work out the values of a and b. Right, so we're going to start by looking at this point here for a specific reason. So if we're using d is equal to a times b to the power t, and we're going to use the coordinate of 0, 3. T and D. So 3 is equal to a times by b to the power 0. anything to the power 0 is 1, so that means that a must be equal to 3. And then we can use any other value, really, completely up to us. Normally, I would use that one, but there's no need to. It's probably more accurate to use this one. So I'm going to say then that we're now using, let's change pen color. We're now using d equals 3 times by bt, and we're going to use the coordinate 4, 48. So, and again, we've got t and d. So 48 is going to be equal to 3 times by b to the power of 4. So if we divide both sides by 3, we get 48 divided by 3 is going to be 16. So 16 is going to be equal to b to the power 4. If we then fourth root, so fourth root of 16 is going to be 2. So b is equal to 2. So a is equal to 3, b is equal to 2. Right, question 24. A curve has the equation y is equal to x squared plus 4x minus 4. The straight line has the equation y is equal to 3x minus 2. Work out the 2 points of intersection of the curve and the straight line. Okay. So this is equation 1, this is equation 2. We're going to put where they're both equal to each other. So we can get rid of y. So x squared plus 4x minus 4 is equal to 3x minus 2. Now, if we take everything over to the left, by minusing 3x and adding 2, that gives us x squared plus x, and then minus 4, so minus 2 is equal to 0. Okay, and this one factorizes nicely. So for two things to multiply together to minus 2 and add together to be 1, we've got to have x plus 2 and x minus 1. So that gives us two values for x, either x is equal to minus 2 or x is equal to 1. So then split this like this. Find the 2 points, yeah. So y is going to be equal to 3 lots of minus 2 minus 2. So that's going to be minus 8. Or y is equal to 3 lots of 1 minus 2. So that would be 3 minus 2, that would be 1. So that gives us our 2 points of intersection of minus 2 minus 8 or 1, 1. Quite a high valued question, 5 marks, so let's just double check that. So if I put, let's do it with, so let's just check by substituting into the first equation. So essentially, we'll call this our checks. Check. So first of all, minus 2 squared plus 4 lots of minus 2 minus 4 is going to be equal to 4 minus 8 plus 4, which would equal minus 8. So that one is right. And then check with this one, 1 squared plus 4 minus 4 is going to be equal to 1. So that one's right as well. So our 2 points are minus 2 minus 8 and 1, 1. Right, that brings us to the end of the paper. Right, so before we go, I'll bring up sort of the Q&A and the grade boundaries. Okay, so I haven't got the AQA advanced Q&A for this paper because it was only, I'm recording this in December. December 25. So it's just over a year after the paper was sat, and they're supposed to be sealed for a year. So they are perfectly acceptable to release them now, but AQA haven't updated their QLA document. So I've taken this one off Sparx. So each of the questions, questions 1 to 24, are linked to their topic area. And any question that you particularly struggled with, I'd recommend some independent study. If you're fortunate enough to have Sparx, those are the codes where you can do a bit of independent practice on that. If you don't have Sparx, it's not the end of the world. You've got the topics there for a bit more independent study on those areas. I've got subtopics, but not a huge amount. But feel free to look at my topic videos for any help if you're not fortunate enough to have Sparx. Grade boundaries for this paper. So these are taken from, and actually we're slightly cut off here. So hold on a second. There we go. So grade boundaries for this paper. So we're looking at paper 3. So that's this one here. So on that paper, for a grade 9, you needed 71 out of the 80, so quite high there. For the grade 8, 62. For grade 7, 54. For grade 6, you needed 44. For grade 5, you needed 34. And for grade 4, you needed 24. And if you dropped off that but managed to get 19 or above, you still got a grade 3. Right, I hope you found that video useful. If you've got any comments, questions, or feedback, please type them into the chat and I'll get back to you fairly quickly with that. I'm fairly good at responding. Other than that, thank you very much for taking the time and watching the video. I hope you found it useful. Please do subscribe if you like, and you'll get notified if you turn notifications on as soon as any other videos that I release are updated. Other than that, good luck with the rest of your revision, and I will see you soon.